So you've had a chance to review some basic algebra, and now we're going to apply that to a problem that you may often have to work with, which is to convert a temperature from one set of temperature units to another. So let's take a look at that equation that we've seen for converting a temperature in degrees Celsius to degrees Fahrenheit. So here is the equation. If we have the temperature in degrees Celsius, we're going to go ahead and multiply that by 1.8, because according to PEMDAS, our rules of orders of operations, we do it in parentheses first, and then after we get this answer, we'll add 32 to it, and that would be our temperature in degrees Fahrenheit. But the question that we've got here is to convert 72.1 degrees Fahrenheit to a temperature in degrees Celsius. So this is a slightly different problem. So how do we go ahead, or how do we go about doing that? Well, a lot of algebra involves working backwards. So let's take a look at what we're trying to find and what we're given in this particular problem. So we're given in this problem the temperature in degrees Fahrenheit, and that is 72.1 degrees Fahrenheit. We're trying to find the temperature in degrees Celsius. So what we've got to do is take a look at this equation and figure out how to get the temperature in degrees Celsius by itself. So we want to make sure that we can isolate this variable algebraically. So how are we going to go ahead and do that? Well, one thing you should notice is that the term that contains the temperature in degrees Celsius is isolated from the rest of the equation by a set of parentheses. So we've got over here this stuff in parentheses. So this stuff is together. And to that, we're adding 32. So the first thing we're going to do is to get rid of that 32 so we can get this, which is together, by itself. All right, so rather than continually copying and pasting everything, or writing it over again, I should say, let's go ahead and copy and paste here. And get rid of that. Let's go ahead and see if we can start to move some things around. So the first thing we want to do is to try to get that temperature in degrees Celsius by itself as much as possible. So I'm going to subtract 32 from both sides of that equation. When I do that, I end up with that 32 gone on the right-hand side of the equation, and I end up with, on the left-hand side, temperature in degrees Fahrenheit minus 32. So here's what we've got now. Temperature in degrees Fahrenheit minus 32 equals 1.8 times the temperature in degrees Celsius. So we've gotten this by itself, but we want to get rid of that 1.8. We don't want this anymore. We just want this by itself. Well, in order to do that, we have to do the opposite of multiplication. We have to divide both sides of this equation by 1.8. So let's go ahead and do that. So I'm going to take my right-hand side, divide by 1.8. The entire left-hand side is also divided by 1.8. So what I'm going to do is I'm going to make that explicit by saying, hey, I'm going to add parentheses there because I'm dividing everything, that whole thing, by 1.8. So when I do this, my 1.8s cancel out on the right-hand side, and my new equation that I'm left with is temperature in degrees Fahrenheit minus 32, all divided by 1.8. which is my temperature in degrees Celsius. Now what I can do is plug in the temperature in degrees Fahrenheit that I was given. So back up here, we were told the temperature in degrees Fahrenheit is 72.1. That's what's going to go right over here. So let's go ahead and do that. So we've got 72.1 degrees Fahrenheit minus 32 divided by 1.8 equals temperature in degrees Celsius. And now we can use our order of operations to solve this. So we do parentheses first. So notice that this up here is in parentheses first. So we've got 72.1 minus 32. That's going to be 36.1. Whoops. 36.1 degrees Fahrenheit divided by 1.8. That's equal to my temperature in degrees Celsius. And this I'm going to use my calculator off to the side here. So 36.1 divided by 1.8 is 20.0555, and it just keeps repeating, so I'm going to put a little line up here that tells me that it just keeps going and going and going. There's my temperature in degrees Celsius. Now the question is, again, that's my calculator, that's what it gives me. What is this going to be when I take into account significant figures? So when we look back at our temperature equation, any of these numbers that are in here will not count for sig figs. So this 1.8 and this 32 are not part of the significant figure calculation. The only thing that's going to count is what's been measured, which is that 72.1 degrees Celsius. So 72.1 degrees Celsius, this has three significant figures, 3 sig figs, which means my answer is going to have 3 sig figs. Remember, we're going to keep sig figs going from left to right. So left to right. So we're going to have to use our rounding rules here. Well, we're going to have to round to the tenths place. We've got a 5 in front of there. So what I'm going to do is I'm going to round that up. So the temperature in degrees Celsius is 20.1 degrees Celsius. So you can see here we've used some principles from algebra to get a variable by itself. And then we've used some sig figs to help us figure out what the actual answer is based on the number of sig figs our measurement had.